Okay. This is the answer for the classwork. The next question, example 9, which has exactly the same structure as example 8. The subtle change is that the function type is changed. Now we have trigonometric functions. Same kind of question. First, find the stationary points. Step 1, derivative. It's easy to forget 4. It's easy to forget 4. Okay. Now, solving first derivative equals 0. I don't usually write equal 0 right after differentiation. It's just my habit. And then you also, if you read the textbook, also they're separate steps. So you need to solve an equation to find the stationary points. So I solve dy dx equals 0. And then I have this trigonometric equation. In this equation, I'll only go for, yeah?
Sorry, I think Joyce is in the waiting, please.
Really? I let everybody in.
Thank you.
Anyway, I'll only focus on the angle between 0 and 2 pi. Now on the graph, you can see the other parts are not in my concern because I only focus on the range between 0 and pi over 2. So when solve trigonometry equation, I need the reference angle. The reference angle can be obtained from your calculator. Now, from the reference angle pi over 3, which is 60 degrees, if you're not completely familiar with the radian, try to use radian as much as possible. So that means this angle. Should also consider there's another angle that has the same cosine value as 60. That angle is in quadrant 4. And this angle is 300 degrees. That's why I have these two answers. And then I have these two values. The y value must be obtained by the original function. So do not substitute this into this. Substitute in the original function. So I get this value in the third form, in the exact value, okay? Exact value. And this one also exact value. I have two stationary points, this and this. You can also see comfort from the graph given. We do have two stationary points. Now, let me check whether or not they're maximum minimum. Part 2. Find the second derivative. Okay, so do it twice. Still have 4. It's easy to get 4. And then do the substitution. So my first substitution says that at this point, the graph is concave down. Now, when the second derivative is negative, that means concave down. So on the graph, you can also see concave down. That means this point is the maximum point. So my conclusion, maximum point, pi over 12, root 3 over 4 minus pi over 12. And then the second substitution. So that means at this point, the concavity is up. So I have a minimum point. Any question? I hope you don't feel a lot different, although in the example, it's just slight change of the function type. Anyway, that will make everything difficult. Classwork based. This time you will solve, you will solve it. Let me know when you're done. Okay, please check your answer with me. I think these two examples are very good revision for solving the trigonometry equation, right? I noticed that you're slower than me. Maybe it's the solving part. Let me remind you. If it's a cosine equation, then you have the reference angle. The other answer is the angle in quadrant 4. When you have sine equation, you have the reference angle, and the other angle is in quadrant 2. Okay, I do remember the sine cosine value of 60 by heart. I do. Okay, now let's go back to the previous page, because we didn't really read this theorem in detail. Now I want to read it in detail. Now, theorem 6.3 says that now we have a way to detect maximum minimum from the second derivative. If it's positive, then it's concave up, right? If it's positive, then it's concave up. That means minimum. If it's negative, it's concave down. That means maximum. Now, we didn't read the last line. Did I? We didn't read the last line, right? During the lesson today. Now let's read it. It says that this one is quite confusing, but let's read it. It says that if y equal f of x is concave up, then we cannot say the second derivative is positive. What does that mean? Now, it's saying that this theorem, the converse of it is not true. Now, read the first. It says that the second derivative is positive, then it must be concave up. If it's positive, but it's not concave, if it's positive, then it must be concave up. But if we say it backwards, it's not true, which means that if it's concave up, it doesn't mean it's positive. It can also mean sometimes 0. Now, let me show you an example. In the next one. This is the inconclusive second derivative test. Let me explain. Now, when we try to find the curvature, find the maximum minimum of a curve, usually we will do the first derivative, and then we will find the second derivative. Now, from the first derivative, I will find the stationary point. Because the first derivative is 0. Here at 0, this point is a stationary point, okay? However, if we look at the second derivative of this function, the second derivative is also 0. Now, what does that mean? That means this one is inconclusive, meaning that we don't know this is concave up or concave down. Okay, now why don't we know? Now look at the second example. Now this one, if you find the first derivative and the second derivative, because that's easy to find. It's a polynomial, easy to find. And from the first derivative, I get this point as a stationary point. Again, a stationary point. Okay. Now the second derivative is also 0, but this time, this curve is concave down. Now in reality, it looks like it's concave down, and this one, it looks like it's concave up. You know what I mean? So if the second derivative is 0, actually we don't know whether or not it's concave down or concave down, concave up or concave down. Now in the third example, where I have this one, so it's the first derivative, the second derivative, okay? And then I have this point is a stationary point, okay? And then if you use the second derivative to test it, at this point, the second derivative is still 0. And this point is a saddle point. I think what I'm trying to say is that while we can get a definite answer, if the second derivative is positive or negative, that means it's minimum and maximum respectively. But sometimes the second derivative test can fail when we get a 0 answer. In this case, in this case, and in this case. In these three cases, when we get second derivative equals 0, it could mean this point is a minimum point. It could mean this point is a maximum point. And it could mean this point is a saddle point. So if this happens, then we have to claim defeat. We have to go back to the first derivatives. So that is the disadvantage of this test, is that sometimes it could fail. Example 10. Look at this one, polynomial. I love that. Find the local extrema, maximum or minimum. Okay. And then f prime. And then f prime prime. Okay. And find the stationary point I need to solve. F prime equals 0. I have 3x squared plus 4x cubed equals 0. X squared, 3 plus 4x equals 0. So x equals 0, or x equal negative 3 over 4. Okay. So stationary point, x equals 0, y equals 0. When x equal negative 3 over 4, y equal, I actually need to calculate, 2764 plus 81, 256. Let me see if it's correct. I think it's fine, right? This value is correct, right? It is correct, right? Okay. So I found out that there are two stationary points. It's here and here. Now I will naturally try to use the second derivative test to figure out. So when x equals 0, the second derivative equals 0, which means I have no conclusion. In this case, I have no conclusion. The second derivative test fails. This one, okay, this one is a positive answer. Therefore, this point is minimum. Now, actually, the question is asking for the extrema, so I need to actually answer the value, not the point. So the minimum point, the minimum value of y. Okay. Now, how about for this one? For this one, I don't know if it's maximum minimum, so I need to do a first derivative test. Do you still remember first derivative test? So I have x smaller than 0, x equals 0, and x is bigger than 0. Okay. That's easier if this is factorized. Right? Okay. So when x is smaller than 0, I mean slightly smaller, slightly smaller. Now how slightly? Don't go too far. Don't go too far. Maybe negative 0.1, negative 0.2. Don't go too far. What is too far? Here is too far. Negative 0.75 is too far because you're not supposed to go to the other side. Now I'm supposed to check here the slope of the curve here, not too far away. Let's say you wonder, oh, what's that on the other side? No, just a little bit. Okay, don't go too far. And I think it's positive. That's easy because this factor is always positive. This factor. Right? And this factor, when x is slightly smaller than 0, that's still a positive. So it's positive. And for this one, if x is positive, then it's positive and positive, that's positive. So it's positive, 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 positive 0, positive. Okay? So that means 0, 0 is not an extremum. Okay? As you can see from the figure. As you can see that this one is a minimum and this one is a saddle. That's it. Why don't you do the classwork? It's an exponential function. Show me the work. You can't show me, but show me your hands. Okay, students. Now, when you have this kind of differentiation, I don't know if you take out 4 and then differentiate what's inside though. Now, this is what I did. I don't know. I don't know. So I will differentiate. I'll put out 4 and then do the product rule. Now, also, don't be scared that if there is an exponential in your equation, that's actually good because the exponential can never be 0. Now, this factor is always positive, always positive. So when you solve equation, you don't have to actually, you don't have a root there. So there is only one root. So that's actually good when you have exponential. And obviously we made a bad choice. This is our bad choice. Bad choice. Shouldn't have done it. Which means this one is also a bad choice. Don't have to do it. Anyway, but it happens. You don't actually have to do it. You should have gone for the first derivative test because that will always lead you to the success. You can always distinguish it's either maximum, minimum, or saddle point. Okay. The textbook does want you to distinguish the extremum point and the extremum value. In this case, you should answer the value, not the point. It's easy. Just look at the question and see if the word point is mentioned. If it's not mentioned, then that is the value. Okay. That's all. I think maybe this lesson, maybe one thing is not so, maybe you didn't realize that even like this curve, we can see that this curve is concave up. So at most of the points, the second derivative is positive, but at this point, the second derivative is 0. So second derivative is not necessarily positive. Sometimes it can be negative in the concave up curve. And this one also in the concave down. Most of the places, the second derivative negative. And then sometimes there is only one point with second derivative equals 0. So that's why. But together, if you are suited with first derivative test, so you can not easily, it takes time. If you can determine the sign of the first derivative, then you can determine you have a minimum point or maximum point. If you can find out the concavity, that's another method. This method is not 100% conclusive, but it's a good way to use it. Okay. That's it. That's it. We have the second part. It's also about concavity, but this time we do not focus on the maximum minimum. This time we focus on these more subtle points where there is a change of concavity. Now we call these points point of inflection. Point of inflection, yes. Point of inflection. It's a strange word. So I'll just point it out to you that the curve changes concavity. It has before and after. Before it's concave up, after it's concave down. Before it's concave down, after it's concave up. Okay, now this morning we already did this part where we highlighted concave up, concave down. Now we need to indicate all the points of inflection. So where are they? I know there is one here. Concave down, concave up. This one here. Concave up, concave down. And here, this one. Concave down, concave up. These ones. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On this strange graph, I don't know what this graph is, but on this strange graph, we have so many points of inflection. Okay, now some of them you already have known them by another name. Now these are saddle points. There are 12 points of inflection. 4 of them are saddle points. Now, what are saddle points again? Saddle points are the points where the first derivative equals 0. Okay? Okay. Now, saddle points are definitely, points of inflection, but not all points of inflection are saddle points. As you can see, this one is not stationary. No. This one has a slope not equal to 0. This one has a negative slope. So these points of inflection, they can be different. They can look very different on the curve. So I have this next practice I will do with you to draw different types of points of inflection as a practice. Today you just follow me. I think not, maybe next week you will draw yourself. You follow me. Now these practice, bear in mind, you must draw the curve and make sure that these lines given are the slope of the curve at that point. But you must draw this point as a point of inflection, meaning that it must have a change of concavity. Okay, so you grab your pen and then you draw with me. Now the first one, this is my point here, so I will have this point. And then I will have concave down and then concave up. So this point is a saddle point. It has a horizontal slope, horizontal tangent, and on the left concave up, down, on the right concave up. The next one, I have drawn this. This is my point. I have concave up and then concave down. You follow? Okay. You can actually find these 2 points on the previous graph. You can see these 2. Okay. Now this one is new. This one has a vertical tangent. This is not very, I don't think we see this very often. I think maybe this is the first time you see it. But still, it has a change of concavity on this curve. I'm going to draw concave down and then concave up. Now the other one, I will draw concave up, concave down. I don't know if you know how to do it. You try. Here it is. Concave up, concave down. Is it? Left concave up, concave down. Next. Now the first figure, I will draw concave down and then concave up. It's not a geometrical concept. You must know. It's not, because if you turn them, they will look different. You see? This is concave down, concave up. You must make sure that the slope is becoming, for the second part, is becoming more and more positive. You see, that's why I'll go that way. Concave down and concave up. The next one, concave up and then concave down. I believe you have seen these two. I believe you have seen these two. This one you can see from the sine curve. Like this. This one you have seen it from tangent curve. Have you? Have you seen them? And the last one is concave. Also, you can draw, you can try. Now today is just a practice. You don't really have to plot it. But I think in the future, you'll be able to plot. This one, concave down and concave up, right? So concave down and then concave up. Concave up, concave down. Okay. I think you have also seen this one. This one is, you have seen it from sine x again. This one you haven't seen. The last one we haven't seen, but you can see it in the cotangent x. But we never learned. We never learned the graph of cotangent x. We know the function, we don't know the graph, but you can see this kind of curve in cotangent for the last one. Now, how about for these two? These two, you can see it from here. You can see it from here, this one, okay? Now, these two actually, I don't know how to find an example. But I think in the future, you have some questions and then you will see them once or twice. Okay? Do they all look different to you? I think you get some sense of the curvature. You get some sense of it. As long as you draw with me. Okay? Now, how to find the points of inflection? We will look for the change of concavity. So on the left is concave up, on the right-hand side is concave down. So we will look for the points where the second derivative equals 0 or undefined. Now, sometimes when the second derivative is undefined, it can also give me a change of concavity. Okay. Now, what are these? These are just symbols. After you find those points, you need to make sure by testing there is a change of concavity, which means on the left. This means on the left. Left. This means on the right. This means the second derivative on the left and the second derivative on the right. They must have different signs. And then we can say this is a point of inflection. I'll show you. 11. This one, y prime equal 4x cubed plus 6x 2 plus 72x minus 13. Y prime prime equal 12x squared plus 12x plus 72. Okay, remember I'm not looking for the maximum minimum, I'm looking for the change of concavity. So I will factorize this. It's negative, oh, sorry, negative. And then factorize it. This is because I know I'm going to solve it. Solving y prime prime equals 0 or undefined. Because when look for the points of fraction, I need 0 or undefined. Now, luckily, we don't have an undefined, so this can be dropped. So I have 12x plus 3, x minus 2 equals 0. I have 2 points. Okay, now where are they? They're here. Negative 3 and 2. Okay, I can find the points. This value. I do have the answer with me. A moment. One moment. -6.3. I have the answer. -7, right? And this one is 28. Okay, I do have I have the answer, so I know the value. Okay, but that's not the end. I'm not going to claim they're the points of inflection. You can never do that. You must do a test. Remember, this graph will not be given to you, so you have to do a test. So you must write that the signs of y prime prime are shown. Do a test. Here you have x, you have y prime prime. Now you're going to test when x is smaller than -3, x is equal to -3, x is between -3 and 2, x is equal to 2, and x is bigger than 2, these values. And the second derivative, the sign of the second derivative. Now it's easy to do because I'm already factorized. This is already factorized. So you just check each factor. So -3, smaller than negative is negative, negative, positive. And then in between is positive, negative, negative. And then larger than 2 is positive, positive, positive. So you check that. And then from that, then you can think about the concavity, because on the left of -3, I have concave up. So you can see the whole thing is concave up. And this thing is concave down. Between is concave down. And then to the right is concave up again. Okay, and then you can claim all those are the, and then you can say, therefore, points of inflection are -3, -7, and the second one is 228. Okay, now remember this part will be marked. This part will be worth 1 mark. If you don't write them, then the mark is not awarded. Will you try? Classwork. Okay. Now the first derivative. No, here we don't really solve the first derivative equals 0 because we're not interested in the stationary points. Okay. So the second derivative we actually need to factorize. So normally I would factorize the first derivative, but in this case I won't. I won't. Solve the equation and this equation. Unfortunately, it's always defined. So there is no undefined places. There are two solutions. You need to check the value of y because I need the points. So the value of y. And then you need to check the concavity. In this case, it's concave up, concave down, and concave up. On the graph, you can also see it. The red parts, they're concave up. The green part is concave down. So there are 2 points of reflection. Next question. Next question is exactly the same, but the function type is changed, which makes everything more difficult. Even if it's with the same type, the same question, a different type of function is more difficult. This one is irrational. The first one is irrational. These are actually the third root. So this one irrational. How do I find the points of inflection? Differentiation. Second derivative. Okay. So that's second derivative. Now I need to solving. Second derivative equals 0 or second derivative is undefined. Now I don't have this solution. This is no solution. No solution. But I have a solution for this one. No solution. But this one I have a solution. X equals 0. Why do I write y? Sorry, it's x. Oh, x. Now this one is a fraction. So normally, not normally, but it cannot equal 0. So there's no solution. Okay. But the denominator equals 0, that will make it undefined. That we also care about. That we also care about because there can be a change of concavity before and after. So I need to check. I found a point. I found a point. Now I need to check the signs. Okay. Now this one, believe it or not, is actually just let me write it here. This one is actually -2/9 times the third root of x to the power 5. Okay. So when x is negative, this answer is positive. Sorry, that was wrong. It's this. One over negative index. Negative index. So when x is negative, this one is negative, the third root is negative, and then multiply negative value, that's a positive. And in the middle is undefined. However, on the right hand side, when x is positive, it's negative. Now, what does that mean? You may need some aid in imagining this shape. So I need to show you the shape here. So this curve is quite strange. I guess we do have an example for the figures we just drew. So this one is quite strange because at 0, you can see that the slope doesn't exist. It's vertical. The tangent line there is vertical, which makes the first derivative does not exist. So the first derivative does not exist, the second derivative cannot exist because the second derivative comes from the first derivative. So at this point, this second derivative does not exist. However, on the left, it does exist, and on the right, it does exist. So I have on the left concave up. According to my signs, I have on the left concave up, on the right concave down. Although in the middle it's undefined, I still call this a point of inflection. I still call it point of inflection as long as there is a point there and then there is a change of concavity. Is that okay? I think that explains why we need to also solve derivative does not exist, undefined. Okay, so conclusion, the point of inflection is 0, 0. So a rational function, irrational function, not irrational function. Right? This one, rational function. D high, low, minus D low, high, divided by low square. It really does not get easy. No. This is negative x squared minus 4, x squared minus 4, whole square. It cannot be simplified, trust me. Cannot be simplified. And then I will do the second derivative. D high, low, minus D low, high, divided by low square. Now watch carefully. D high, negative 2x times low, which is x squared minus 4 whole squared. D low, which is 2u du dx. Here you may miss out this one. Two u du dx. D low high. Okay. Now this one, the simplification. Let me show you again. I need to also teach you. You also need to learn how to simplify these with a lot of negative signs. I plan to do this, copy it once, and change the signs, and also put the 4x in front. So 4x, x squared minus 4, x squared plus 4. Okay, do not expand. Take out. Take out 2x. Okay, and also x squared minus 4. You are left with negative x squared plus 4. You're left with negative x plus 4 plus 2 x squared plus 4. Okay, and slowly you will get 2x, and this bracket is x squared plus 12. And this one is x squared minus 4 cubed. Make sure that the fractional one is almost, I think it's even worse than the trigonometry, because the quotient rule will make everything more difficult. Just need to do it slowly. Okay, now let's solve. So solving y prime prime equals 0 or y prime prime undefined. I have x equals 0 for this one. Now there are a few factors. You can see this one, this factor, and this one. The second factor cannot equal 0, so there is only one solution for y prime prime equals 0. Okay. Now how about undefined? Undefined, actually we have more solution, more solution. Because the denominator can equal to 0 for two values, which is 2 and negative 2. So x equal 2 or negative 2. So this factor, you can look for the undefined part. So denominator can tell you where it's undefined. The numerator can tell you where it's 0. Okay. Now, let's find out where the points are. So when x equals 0, y equal 0. When x equal 2, y is undefined. When x equal negative 2, y is undefined. Okay. Now, if we check the signs, x, y prime prime, you can check the signs. Negative 2, between negative 2 and 0, x equals 0, between 0 and 2, and x equal 2, and x is greater than 2. I can actually check each section. Okay, now bear with me. Bear with me. The second factor is always positive, so I don't have to look at it. The second factor. So when x is smaller than negative 2, that means negative numerator, positive denominator. So I have negative. I think I forgot one thing. How about x equal negative 2? Just sorry, I missed out one. X equal negative 2. X equal negative 2. I need one more box here. Okay, does not look good. Now this one is undefined, so I write maybe a cross C. I don't want to write undefined. I'll write cross C. Now between -2 and 0, I have negative numerator and negative denominator, so positive. And this one is 0. This one, from 0 to 2, that is positive, negative, negative. And this one is crossy, does not exist. And then bigger than 2, positive. Now, what does that mean? For checking the signs, you can still figure out the concavity, which is concave down, concave up, concave down, concave up. Now, what does it look like? There is concave down, concave down, concave up, concave down, and concave up. Exactly. Now you can just line them up like that. Now this part is this part is this part is this, sorry. This part is this, and this part is this. Now you can actually line them up. So there are 3 times of change of concavity. However, we only have 1 point of inflection because this one is a point, whereas there's nothing here. Now here at -2, there is a change of concavity, but the point doesn't exist. Therefore, we don't say, oh, there's a point of inflection. There's no point, but there is a change. Just no point there. Okay, your final answer? The point of inflection, 0, 0. Okay. Now, if you go, now let's do a comparison. At this point, part A, there is a point there. Although the derivatives are undefined, there is a point there. There is a change of concavity. So you have undefined. Now here you have undefined, but that's okay. The point is still there. We call it point of inflection. This one, it's undefined. Now, undefined, undefined. There is a change of concavity, but there's no point there. So we don't have anything here. We only have 1 point here in the middle. Is that okay? Why don't you try? Why don't you try? Okay. If you have no question, you can leave.